Okie dokie. In this video, we will be covering homework 2, maybe problems 1 through 4, I think is a good amount. So let's get started with number 1. Integration by substitution is related to which or what differentiation method? So the differentiation method would just be the chain rule. The chain rule, because the chain rule is designated for finding derivatives of functions with multiple layers. So inside layers and outside layers. For example, sine of x squared plus 3. The inside layer would be x squared plus 3. The outside layer would be sine. And when we find a derivative of something like this, or when we find the derivative of this, we get the derivative of the outside layer, cosine. We leave the inside layer the same, x squared plus 3, and then we separately multiply by the derivative of the inside, which is just 2x. So the idea is, in using chain rule, we get these two pieces. And if we were working in the opposite direction, finding the integral of this dx, then, we'd be kind of identifying like what's going to be our u, and can we find our du, the derivative of that expression, in the same integrand? And so because we can, in this case, we can see something like x squared plus 3, and we can see its derivative in the same integral, that's sort of the indicator that we are using u substitution. So that's why it's kind of related to the chain rule. I don't know if they ask a second question here, but hopefully this part kind of answers it. So the integrand you'd be looking for is like something with multiple parts where you can see a u and a du of some sort in the mix. Hope that makes sense enough. Let's keep it going to number 2. Number 2, we are going to demonstrate the process of u substitution. They say use substitution to find the indefinite integral. So the first step would be to identify the u, and then identify a du, and then make our substitutions, making sure we get rid of all of the x and dx terms within the integral, so that we're basically rewriting this entire integral in terms of u's and du's. Then what that should do is simplify the integral so that it's easier to evaluate. Then we evaluate it in terms of u. Then we get everything back in terms of x. Got it? Let's go. Identifying u. Typically, u is found as like the inside layer of whatever crazy stuff you have going on. Typically, u is inside parentheses. Typically, it's being acted on by some outer function. In this case, that outer function is the power of 4. That's all my tips. Once we identify u, we identify the du. Du is the derivative of u. So what's the derivative of 3x minus 14? Well, that's just 3. And you want to make sure you tack on a dx, because we can see it as like the derivative of x is just dx, the derivative of x. And then this is the method I will suggest. I will get dx by itself here. The way to get dx by itself on this right side is by dividing by 3. So du divided by 3 is equal to dx. Once I have my u and my dx, I typically then make the substitutions into the original integral in order to rewrite the original integral. 3 on the outside stays, but we know that 3x minus 14 is u. So we now have, instead of 3x minus 14 to the 4th, u to the 4th. And once again, in place of dx, well, we learned that dx is actually equal to du over 3. So we're going to plug in du over 3 in place of dx. What we have now is the entire integral in terms of u and du. Notice how we got rid of all the x's and dx's. So now, before we evaluate, typically it's helpful to simplify anything if need be. In this case, 3 cancels out with, a 3 on the bottom. 3 divided by 3 is 1, in other words. So we are really just left with the integral of u to the 4th du. Now that we've simplified the integral, gotten it all in terms of u and du, we can evaluate it. What's the antiderivative of u to the 4th? Using the reverse power rule, we add 1 to the exponent, and we divide by that new exponent, and we add c. But then before leaving it just like this in terms of u's, we have to get everything back in terms of x by plugging in 3x minus 14 in place of the u. So we have 3x minus 14 to the 5th over 5 plus c. And that is our answer. Hope that makes sense. Let's keep it going. We got 2 more that we will cover in this video. Number 3. Again, u is found inside parentheses. We find its derivative. That's just 5. Tack on dx. Solve for dx by dividing by 5. Sub in the u and the dx. So we have 10, or I guess the d over 5 in place of dx. We have 10 on top. We have u to the 3rd on the bottom. And in place of that dx on the end, instead of writing dx, we are going to write du over 5. Again, that comes from here. So we've used our u to substitute, and we've used our du over 5 to substitute. So now we have the whole integral in terms of u and du. In other words, gotten rid of all the x and dx terms. Now we ask ourselves, can we simplify? 10 over 5 is equal to 2. So you could leave the 2 on the inside if you prefer. So 2 over u cubed du. Or you could pull the 2 out and leave a 1 there. It really doesn't matter. So 2 integral of, now our question is, what's the integral of 1 over u cubed? In order to find this, it typically helps to rewrite this term with negative exponents. Leave the 2 on the outside, but now we still use our reverse power rule with the integrand there. So we add 1 to the exponent. Negative 3 plus 1 is negative 2. And now we divide by that new exponent, negative 2. When we simplify this, we get negative 1. So I'll say negative 1. And then u to the negative 2 is the same thing as a u to the positive 2 in the denominator. And we can add c to that. And then we cannot forget to get everything back in terms of x, because our integral is with respect to x. So your answer better be with respect to x. So 5x plus 6 is our u. So our final answer is negative 1 over 5x plus 6 squared plus c. Hope that makes sense. There's the full problem. Let's go on to number 4.